Okay, so we should be about on page 40 in your books, right? What you guys were doing on Monday at the end of class is that you made a graph, okay, from the data that we collected when we went down to the gym and did our little experiment, right? Seeing what the carrying capacity of the Serengeti would be with the number that we had. Okay, so what was our carrying capacity? Should be 7. Because that's what could actually survive in our area based on what? The amount of grass that was available, the resources that were available to it. So what would happen if we had a big rainstorm and a bunch of grass flourished? Okay, so it would be able to sustain more wildebeest for a period of time, right? Okay, if it did not continue to grow at the same rate where there was a lot of food available for them, it would only be for a short period of time that they would be able to survive in that area at a higher level. Okay, so with that, what you need to do is making sense of what the data is telling us. Would help if I was in the right lesson. Okay, so as a group, I'm going to have you guys answer the questions that are on page 40. There are 4 of them. Okay, so talk through those as a group. Come up with the best answer for you to write that down.
Get out over the Go, Vanessa. Go.
After that, there's a decrease, and then it just stayed at 7.
I'm gonna guess that we're using this thing up here.
Okay. Sounds good.
According to my calculation.
Just like, right what they did. Right what they did, like that. Like, and then it stayed the same. Their population increased.
No, I'm still writing. Go.
There was.
Carson Owens here.
I'll get those questions done. Yes, no, maybe.
Yes.
Okay. So you all developed a mathematical representation of our data by creating a graph and making sense of the pattern it can help us see. Can you think of other kinds of mathematical representations?
Addition.
Subtraction.
Decimals.
Fraction.
Okay, a mathematical representation of, so like how numbers represent something else. And then using those numbers and making sense of them, what are the numbers actually telling us?
Geometry.
So I'll have you guys made graphs like this before. Okay, you've had to do it in other classes, right? What math class are you guys all taking?
Language arts.
Math class. Geometry.
Yeah, it sucks.
It don't make sense.
Well, it's math. It literally makes sense.
Like, all I
She
do
does it for
is
us,
make
so-
circles with the compass.
She's so mean.
You can make a full circle if you want to.
Girls, over at that table. You have it.
Oh, you guys have such a rough life.
Yeah.
You can draw the little thing.
What?
You can draw the full circle.
Yeah, she reminds me like every time.
Okay, so anyways, one kind of mathematical representation that might help us make sense of our data is something called an algorithm. Where have you heard that before?
Language arts.
What?
Computer class.
Computer class? Okay, well, what'd you learn about an algorithm in computer class?
It's like an
The CPU.
equation or a system.
An equation or a system? Okay.
Wham.
Why did he just wham? I don't get it.
Where else have you heard of an algorithm?
Oh, yeah, there's
Movies?
one movie. Space Check. Yeah, the second Space Jam.
I haven't seen the second one.
Yeah.
Well, LeBron James is not as good as Michael Jordan, so why would I want to watch it?
Yeah.
False. Can't be.
Larry Bird on top.
How many of you guys watch TikTok?
I don't know. Probably.
I don't have to.
How many of you guys watch Instagram Reels or whatever?
I don't have
Or Facebook Reels or anything with
It's got YouTube shorts.
YouTube Shorts.
YouTube Shorts also, yes. So all of those use what?
Algorithms.
An algorithm, and it will feed you more videos like the ones you've viewed because you obviously like those, right? So if you watch one video on LeBron James,
Third.
what's gonna keep coming up in your stream? LeBron, right?
LeBron.
Okay, or things similar to that. So other basketball players maybe, or basketball games, or anything to do with basketball, right?
Larry Bird.
Okay, so that is using an algorithm. So taking the data, what you viewed, and giving you more like that. So how does that relate to this?
I don't know, the same pages just keep popping up. Graph, notice and wondering.
How can we apply the term algorithm to the wildebeests?
It kept giving us 7 wildebeest.
Okay, so we got repeated data, right? Based on what?
Resources that are available.
Okay, so depending on the resources that were available, we kept getting very consistent numbers, okay? And that keeps your population in check. So, when we are talking about algorithms, another way to understand the patterns that we see in the data from one generation to the next, and one way that we can write these types of patterns is using an if-then statement, which is also how we write hypotheses. Okay, so if the number of wildebeest is less than the number of grass, what's going to happen?
All of them will.
All of the wildebeest are going to survive, and
Half of them will be.
half of them will reproduce, because we're assuming half are female, right? Okay. So that is an if-then statement. This is an algorithm. So if we took and we wanted to expand this data table down, so we're at 13 years. If we wanted to go to 50 years, what would our data look like?
The same.
Pretty much the same as what's happening here, right?
Think we should try it just to make sure?
No.
Yeah, better go back to the.
No.
Better go back to
Okay, so if the number of wildebeest is less than the number of grass, then all wildebeest survive and 50% of them are going to reproduce. Okay? What if that's not the case? If the number of wildebeest is more than the number of grass,
Then they're all gonna die.
not all of them,
Well, the weak ones will. So you.
well, the ones that don't get the resources, right?
Yeah.
Then some of the wildebeest will die because they're not getting the resources they need. And still, 50% of them are going to reproduce, right?
Nope.
Theoretically.
We should go try it just in case.
Hmm. I don't think so.
But like those are theories. We have to test the hypothesis.
Oh, let's see.
It's not that cold.
Last night I had to break a sheet of blanket out. So cold.
I almost had to have a heater too. It was cold.
Yesterday, someone wore numbers to practice.
We just have practice.
I wore my long johns yesterday. It was too cold out for me.
It was like 50.
It was like 40. It was like 50. It was like 40. We weren't even outside.
Okay, so let's go ahead and answer the questions from part 2 there on page 41.
We had a fire gun. We were just trying to stuff. Still too cold in here.
It's hot in here. Turn the air down so it'll kick on.
You're crazy.
We should go crack that
What?
crack that.
Well, I actually have it like sealed up because it doesn't seal right. I have it sealed up.
My
And I
heater
don't
gets so
want
bad.
to have to.
Pick up that I have to roll my windows down.
Well, turn your heater down.
Turn the heater.
Well, it takes like.
Are you guys answering questions 5 and 6? That's what you're supposed to be doing right now.
It takes
I literally said answer questions 5 and 6 on page 41.
Yeah, I think I heard you say that now that I think about it.
Yeah, and you are all like staring off into space like
Just, it's easy. We just talked about this goal. We know we just talked about this. If the wildebeest are greater than the number of grass, the wildebeest that can't get food will die.
No. Actually, no. The wildebeest. Oh, wait, no.
They died, and then somebody died. Use evidence from where they actually
More grass, more wildebeest. Less grass,
Okay,
less
go.
wildebeest. What'd you sign?
Heads up, I will not be here
More
tomorrow.
wildebeest, less grass,
okay.
less wildebeest.
I got the
I'll be like 10
8th grade,
wild beasts.
Oh yeah, that's
Conservation
right. Have
we'll
fun.
see, because it's at the Butte Golf Course, and still got a 65% chance of rain, so
It is cold.
Fun, 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 fun.
yeah, I won't be surprised if they cancel it because it's cold.
Cancel the what?
The 8th grade conservation day.
They want to go learn about grasses.
It seems strange to have it so late in the year. Like it's an outdoor event, so why would you wait so late? Why wouldn't you have it in like September?
Oh, last year it was like at the end of September. That made sense this year.
Because October, you're
Because
could have any type of weather. You could have snow on the ground.
It could be blistering, yeah.
Oh, so you just skipped it.
Aiden, you have a big day tomorrow. Isn't tomorrow decide if you guys gonna stay or not?
Whatever, let's go to the box.
More grass equals more wildebeest, less grass explain the relationship.
That's wildebeest equals less grass.
Less grass. I wrote it wrong, but you know what I
They
mean.
populated the area of grass, then overcompensated.
Less grass.
Then with the perfect amount, then the other grass support them.
I was parent teachers yesterday.
So good.
Yeah, she,
So like, was there,
yeah, she was filling my mom with faulty information. Ooh.
was there like anybody you like had to sit down to the parents and like have a serious conversation? No.
actually don't think he said anything bad.
Must have, because when I got home, my mom came and slapped me around because of you.
Lies.
Nope, it's all true. I have the scars to prove it.
Okay.
So that was
Right here.
Got kicked in the tush.
If you got slapped around, you wouldn't have a scar from that. Especially half a day later. Half a day later, you're not gonna have a scar.
He said
Well, I did.
scratch.
Yeah, I said scratch.
No.
I don't know what you're hearing.
You want to go back and listen? I got it recorded.
Oh, shoot. Yeah, let's do it.
Let's steal the tape from her.
Oh yeah, we'll
we should
just
just like listen to
we'll
all
hack
of
into the
us.
algorithm and we'll reverse it.
We done?
Yes.
No.
Yep.
So just on the bottom there, you should have a little bit of space. You can write the answers to these questions after discussing them. What is one major takeaway from simulating the Serengeti using a kinesthetic and mathematical models?
It's not gonna be 100% right.
Okay, not 100% right, because that's just not how nature works, right? But also, did we represent the wildebeest and the grass accurately?
No.
Yes.
Yeah.
Probably not, because we had a total of 17 people, right?
We should gather everybody in the school.
Pretty much 4 million.
Yeah,
It's not even 4 million.
1.3 million or whatever it is. Okay, well, if there's 1.3 million of the wildebeest, how much grass is there?
Like triple the amount.
Probably more than that. Probably.
Are
So,
we considering grass as like one singular blade of grass?
Or is it
like
just
one
like
plant of grass is one species, like
So,
an
like-
individual organism.
So like one like group?
Yeah.
What if it's not a bunch grass?
a bunch
Yeah.
of-
What if it's a rhizomatous plant grass?
What if it's
Oh,
Then-
look at this smarty
What if
pants.
it's a
Then-
soloniferous?
Theoretically, then, like, you should be able to cut those rhizomes and they'll be able to survive, right?
What if it's just like
I don't know. I just knew that word. Didn't pay
You
attention
look,
that
you sounded smart for about that much time.
Good job, man.
much. Hey.
Hey,
More than that.
so what then are some limitations to our model?
There's only 7.
It's not right.
So the numbers weren't exactly correct, right? What else? Else were some limitations?
The space.
I mean, yes, but
I can
think
tell- I can
think
tell you
more
I did
think
got
more
the
in
size
terms
of
of
17.
like what you guys were supposed to be representing. So what were some limitations to that?
We didn't do the horns good enough.
No, that's not what I'm talking about. I'm talking about actually like when we think about the wildebeest and the grass and what happens to them throughout the course of the year. I'm not talking about like the things that we were doing.
The wildebeest migrate.
Okay, so migration patterns could have an effect on it. We know that as they move around to different areas, there are some deaths due to different things. We talked about the anthrax, we talked about the predators. Okay, so deaths are not only due to lack of food, right? What else have we talked about that is a limitation to what we were representing?
Natural disaster.
A fire.
Natural disasters as well. What?
We did a fire. A fire.
A fire. Okay. Do we think 50% of the population of all wildebeest are female?
No.
Probably not exactly 50%, right? So that number could be misrepresented. And then do you think every single female will reproduce each year? Do you think that sometimes maybe they have more than one offspring per year?
yes.
Or they
Possibly.
have it and it dies.
Okay, so a lot of different things that could happen. So they could not be pregnant at all. They could have multiples. They could have an offspring and then it dies for whatever reason, right? So those are some limitations to what we were modeling, right? And do you think there is more evidence that we could gather to help us understand wildebeest growth population?
Yep.
Always, right?
Totally.
Okay, so we could look at actual wildebeest populations, and based on what we know about this algorithm we developed, we could theoretically create a graph that shows population growth and population, like the carrying capacity of that population, right? Theoretically. Okay, just based on the information that we figured out with our data collection and creating our graph. So we could look at actual numbers of wildebeest and the grass population there. Just takes a little bit more time and a little bit more thinking for us to do that. But could be done. It could be.
Yes.
We should do it and see how long it takes. Should make a hypothesis.
Okay, so we are going to start our next lesson. It's supposed to be the end of a day, so. Anyways, by digging deeper into what is really happening with the wildebeest population and the grass in the Serengeti. Okay, so what we figured out in this is what? What did we figure out from our simulation we did on Monday?
No idea.
There is a limiting factor, right? And because of that, a population can reach a carrying capacity. So what population it can actually support because of that limiting factor. In this case, we are talking about the grass, right? What do you predict we would see if we looked at historical data for wildebeest populations in the Serengeti?
Skeletons.
You would kind of see the same thing.
You think you would see like very similar population patterns?
Yeah.
Okay, possibly.
I was thinking it's gonna be way different.
Like,
Why would it be way different? It might be the same, it might be different.
maybe if like before it was the park, I think it would be different,
Because of,
like poaching and stuff.
okay, so poaching is something that's supposed to be better controlled, right? So one of the reasons why they developed the park was to prevent poaching from happening. Do you think it still happens?
Yes.
Yes, probably.
Not
Do you
as
think
much.
it's probably less? Because what happens if you get caught doing it?
They shoot you.
Public.
They're like, oh, you shot a wildebeest, I'll shoot you.
39 lashings.
So pretty significant offense if you get caught, right? So something big would probably happen. Okay.
Alien comes and shoots you.
So do we think that grass has always been a limiting factor?
Yeah.
Probably, because food is a pretty significant resource that all organisms need. They need some way to get the nutrients they need. Okay, so in this case, grass for the wildebeest, right? So we have have an idea that grass is a limiting factor for wildebeest, just like the rain was a limiting factor for grass. So let's investigate how that really worked in the Serengeti. So let's see.
Let's see.
So since the late 1950s, scientists have been counting wildebeest by airplane each year during the wet season in their zebra-striped plane. Wouldn't that be
All
fun?
wildebeest.
I would say they are.
How do they count that?
I'm guessing like a scanner.
Now there's one guy that's puts his head out the plane. 1, 2, 3.
No, you gotta count fast since you're going
They
fast.
find
You gotta
someone
be-
like needing to count them.
Yeah, I'm really good at counting.
and he just makes tick marks.
Yeah, I'm really good at counting.
They
You
hang
know, I
him
should
by
know
a
how to
rope
be
and
good.
he just sits there and like finds
Oh yeah, and he like spray paints the
Yeah, I got some of that spray chalk and I just
Just spray them.
Yeah. that way I know I've
Yeah,
already
you
counted
just
them.
you just run through the chute and you're like, and then Aiden messes up and they gotta send them all over.
1.1 mil. I lost count. Right on back. 4 days later.
How do you have a point?
I don't know, they get points on there. They ended at like 1.3. So I ended at 1.1.
He said 1.1 million.
Oh, I thought you meant like
like-
1.3 wildebeest.
Okay, if we look at page 42 through 44, we have a graph on there that we have already seen, right?
Yeah.
Sure.
I would assume.
When we were looking at rainfall data, if I can find the page,
Maybe look on 67.
32, page 32, okay? When we were looking at rainfall data, right? Okay, so this is still rainfall data, okay? But we are going to relate that now to the wildebeest population, okay? Looking at that data. So, we are going to start our analysis of this population data. We're not going to get finished today because we only have about 10 minutes left in class, but we are going to get started on that. So, looking at, there might be another graph I need to print for you guys.
Oh shoot, take minutes like 13 minutes.
Like, because that graph, it does not look anything like ours. Right.
They're similar.
They're similar. You see similarities between them?
Yeah, ours have blue dots and so does ours.
That's
So they're
not,
just wet.
that's not what I was getting at.
And I'm guessing the range about wildebeest.
You're asking for Bucko.
Oh, give it to me.
Wait till PE.
We're probably gonna be in the weight room, so it doesn't even matter.
It's studied.
No. It's studying.
Yeah.
Oh my gosh.
I kind of hate it in there because like it's PE, and like you can't just not do anything, even though I don't do anything.
Well, Aiden, what do farmers carry? And he's over here carrying like 5-pound weights.
I quit at 250 the other day. All right, that's a go. Well, then I go over and lift fractions.
Yeah, I did the
There's
same.
something Wednesday.
Yeah.
Okay, well, we have this one on a different document,
Are we-
which doesn't look like the one we just looked at, but, okay, so this is looking at Serengeti wildebeest population from 1961 to 2012.
That looks just like ours.
Does it?
Looks more like Chris.
Funny? No.
So using that. So let's analyze that data then, start our analysis. So making sense of the historical wildebeest population, starting with question number 1 there, and looking at our data from 1961 to 2012.
I was 3.
Okay.
I was 5.
My dad was 1 in 1961, so
So how old was he in 1967?
7.
Your dad makes really good pickles. I went into the lunch bar and I.
Oh, I was gonna say, you better not have been in my pickles.
No.
Then that's fighting words. I would tell your mom.
Nope. I just went to the bar, chatted it up with them, and got some pickles and ribs.
Why were you in the bar? What were you doing in the bar?
Felt like going to the bar.
When?
This was a long time. It was still summertime.
No, he just pulls up to the bar on
He does.
Yeah. I just go to
He does
brunch
make the best
bar.
pickles though, doesn't he?
Yeah, they're pretty good.
So does Aiden go into your house?
I have
He comes to my house, but usually they're just down in the shop.
Except when I tried to make mac and cheese.
That was terrible. And it burned to the bottom of the pan. Okay,
Did you put water in?
guys are supposed to be analyzing data.
My bad.
Question number 1, describe how the historical data compares to the data that you collected during your simulations.
So like,
Supposed to be discussing and writing it down.
It looks similar.
I think it looks similar.
It looks similar.
Ian, does it look similar?
How does it look similar?
Like the way they look.
Discuss it with your group, not me.
Goes up.
It goes up.
Discuss it
and
with
then
your
goes down,
group.
And then it goes back up.
Ah, you guys are struggling today.
Down,
I'm looking at the heckin' graph.
up, and then
It goes up,
sideways.
goes down,
Good explaining.
and then goes back up.
Even though I'm doing it. I have pencil lines.
I seen a post on Facebook
You look at Facebook.
about how West Holt was like champions in like range judging.
They cheated.
Aiden cheats.
Yep. Every day.
They didn't almost get their card pulled like you.
Yeah.
I was not getting my card pulled.
Okay, question number 2. Before 1960, a disease called rinderpest was killing many of the animals in the Serengeti. The disease spread from domestic cattle to wild animals like wildebeest and buffalo. In the early 1960s, cattle began being vaccinated against rinderpest. By 2011, rinderpest was considered to be completely eliminated. So use this information and what you figured out during the Serengeti kinesthetic model and the graph above, not the graph above, the one on the board, to explain what happened to the wildebeest population between 1960 and 1977.
It grew.
But explain what happened.
The populations.
Why might it have grown?
It increased.
Ass. What'd you say? The population.
Population increase.
Well, it says that in the early 1960s. Yeah. They were getting vaccinated. There was no
That food.
Oh my god, I'm not okay.
Yeah.
I like mixing.
I'm ready now.
What are you writing?
I say we call it quick.
So we could consider rinderpest to be what prior to that time?
The disease.
Well, yes, it's a
The
viral.
limiting factor.
It's a virus, so it would have been what, Ben?
Limiting factor.
A limiting factor
He
prior
got
to
that
that.
from me.
Yeah, he got that from our table. That's what we wrote down.
Okay.
They died in there.
You can come check our books.
And so since the rinderpest was eradicated, what happened to the population?
It decreased.
Woo, it expanded pretty rapidly, right? Because
It did.
took out that limiting factor. Lots of grass available, so not much for competition, right?
Nope.
So, how can you calculate the rate of change for the wildebeest population during this time period? How do we calculate the rate of change?
A squared plus B squared equals C squared.
I don't think so.
Silly you.
So from here to here,
Yup.
rate of change?
Year over, population,
How do we find the slope?
rise over run.
Rise over run.
So 5,000.
5,000.
What do you do?
I'm looking at the graph.
Where do you get 5,000?
Or 50,000, I can't read that number. 50,000?
Yep.
500.
The bottom one?
Yeah,
Yeah,
how many zeros are there?
I think there's
That's
5.
5 million then.
For sure, that's 500,000. That's 500,000.
That's 500,000.
That's 500,000.
That might be 500,000.
That's about how much Aiden has in his bank right
Yeah, I don't know how to do
Yeah.
that.
So this is
In
telling
debt.
us,
Like 500,000.
Casey has his basement.
now. Come on, bro. This
so if we're starting, it wants us to start here. Go to here.
Oh shoot, looks like it's away from mom.
Oh my gosh.
Harder.
What a shame.
Guys, you need to follow by Carter's rules.
Wait, you're.
At that table, you can sit at the table.